In this video, we'll walk through the historical background of the periodic table and see how this powerful tool of chemistry came into existence. What is the periodic table? The word periodic means something that repeats after a fixed interval. In chemistry, it means that after a certain gap, the physical and chemical properties of elements repeat. The periodic table is a systematic arrangement of elements. It helps us study their properties easily, compare them, and predict their behavior. That's why the periodic table is called the symbolic language of chemistry. This is the modern periodic table. But it was not discovered until many scientists contributed. Here are the main contributions. One of the earliest attempts to classify elements was made by Al-Razi. He arranged known substances based on their physical and chemical properties. He divided elements into three categories: gases, liquids, solids. Although simple, this classification laid the foundation for organizing elements scientifically. Later, Dobereiner introduced the concept of triads. He arranged elements in groups of three based on atomic mass. In each triad, the atomic mass of the middle element was approximately the average of the other two. This showed a relationship between atomic mass and properties. However, as more elements were discovered, many did not fit into triads. Because of this limitation, Dobereiner's idea was eventually rejected. Then came John Newlands, who proposed the law of octaves. The word octave means 8. He observed that after every 8 elements, properties repeated, just like musical notes. This concept worked well for lighter elements. But at that time, noble gases were not discovered. When they were later found, the pattern of 8 no longer fit. So, Newland's law was also rejected. Dmitri Mendeleev made the most important breakthrough. He arranged elements in increasing order of atomic mass. He organized elements into vertical columns called groups, horizontal rows called periods. The genius of Mendeleev was that he left empty spaces for undiscovered elements and even predicted their properties, and later, he was proven right. But his table had problems. Isotopes like hydrogen, H, squared H, cubed H, had different masses. Some elements with different properties were placed in the same group. Because of these defects, Mendeleev's table was improved later. Finally, Henry Moseley solved the confusion. He discovered that atomic number, not atomic mass, is the real basis of periodicity. He arranged elements according to increasing atomic number. This resolved the isotope problem, because all isotopes have the same atomic number. Noble gases were placed on the extreme right side. Misarranged elements were corrected by forming subgroups, such as 2A and 2B. This modern approach formed the foundation of the periodic table we use today.